Hello, my name is Sesarius Egi and I represent my group for explaining the work project of machine design Gearbox. My group is Wijaya, Fabrilian Handoko, Kristophorus Peter, and me myself, Sesarius Egi Budiman. So this is a project of machine design given by Leo. First thing first, let's see the design. This is the design of our gearbox. As we can see, we use about 6 different gears here to attain the minimum ratio of 1 to 5. The first gear is a gear with 35 teeth, and then the second gear is the gear with 50 teeth, and it is one shaft with a gear of 25 teeth, which connects to gear with 45 teeth, and the gear with 45 teeth will transfer the torque into the gear with 26 teeth and connects with 58 teeth. So all in all, the ratio will be 35 to 50 times with 25 times 25 to 45 times with 26 to 58. The total ratio of this gear train is about 91 divided by 522, or about 0.174. It is between 1 to 5 and 1 to 6 with opposite direction. So if we give an input to the input shaft and it is clockwise, the output in output shaft, this one, will be the opposite direction. See, if it's clockwise, the input, the output will be counterclockwise. And if we give the input about 2800 rpm, the output will be about 488 rpm. So that's all about the ratio of our gearbox. Now we talk about the bearing. For this gearbox, we use 3 bearings in total. The first one is 6205, a bearing with the inside diameter of 25. Why we choose this one and this one a bigger bearing than the others? Because we assume that there's load happening here, because it's an input shaft and this one is output shaft. So the other one is 6004. It is the bearing with the inner diameter of 20 millimeters. We use this one occasionally. Basically, it's for every shaft, to hold every other shaft. But especially we use 6202 for this one, because this gear is a gear with combined shaft, so this one has no hole. The shaft is combined to itself. So to solve that, use weldments here, like here. See, so we made the shaft, and then this one and the shaft will connect, and we will weld the two of this gear and shaft. And we use bearing with 15 millimeters in diameter. So next is about the shaft. The shaft material is steel 37. Why we don't use aluminum? Because steel 37 certainly can hold bigger loads, because our gears are made of cast alloy steel, and each one of them weighs about 1 kilo. As we can see, this one weighs about 1600 grams. And for every gears we use press fit of the shaft, so we don't need any keys here. We don't need any keys. We also don't need any set screws. It all depends on the press fit tolerance of the shaft. So once it's pressed with the hydraulic press, it will transfer the torque greatly. We use the press fit P6 here. And then for the case, we use both acrylic and woods for the case. Why? Because the acrylic purpose is for the easiness of machinability, because we can machine the acrylic using CNC to make the hole for the bearings, to make it more precise. And it also is a rigid material. Yet for the wood, why we choose wood? Because wood is, of course, it is cheaper than acrylic, and also it has its own advantages. It has the dampening effect, both sound and vibration. And for the fasteners, we use here tap bolt M3 with fine thread, because tapping fine thread into acrylic could be tricky, but we can use lubricants. For example, can you put oil to tap the M3 to the acrylic to prevent it from damaged. And then to fasten the acrylic to the wood, we use nails with the diameter of 2 millimeters here. So I think that's all. In conclusion, our gearbox will change the direction of the input, and also change the speed, reduce the speed, and increase the torque with the ratio of 0.174 for the speed, and it's about 5 times the torque here in output shaft. So that's all our gearbox design. I hope that you are glad of it. That's it. Thank you.